So I'm here to talk to you guys about promises. Promises are kind of a building block of how we do work today with a lot of different asynchronous things. And I mean, they're kind of honest, they're kind of not. I'm going to make some terrible puns if I can. At my work, I'm probably the worst person with puns, so if I make a really good pun, if you guys just roll your eyes and moan a little bit, I know I got a good one. If I miss any, you guys want to pull some out at the very end, that's fine. I get it. You know, puns are fun. I'm terrible at them. Hopefully you guys have had a really good time at Midwest.js today. I guess let's get started. So like I said, this is going to be about JavaScript promises and asynchronous honesty. So promises, what are they? I mean, they solve quite a few problems. They're usually solving asynchronous problems today, and they serialize asynchronity. I'm going to be focusing a lot more inside of the browser today than inside of the node space, but the things are still going to be applicable both ways. But one of the huge things that promises can bring is that they make things more readable. So this is one of the things that I would say is one of the inceptions of, or brought about the idea of promises. Everybody knows callbacks. Callbacks are a powerful tool. We use them all over. It's a thing, and given enough space and time, they can get quite overrun. Bad things can happen. And that brings us about to something like this. You know, it's not so great. It becomes really hard to read, and there's a lot of stuff happening in here. It's you know, don't take some time to read this. The whole idea is that, you know, let's burn it in a fire, let's call it done. But callback hell is a manifestation of overly nested callbacks. Notice the nice pyramid that brings us to callback hell. So enter promises. Promises are a solution, may even be an A+ solution. There we go. I even got a clap out of that one? Yeah. But this discussion actually stems from countless hours of discussion with my own devs at my work and trying to work through various problems. So if you read the abstract for this, I talked about 3 different things. As I was going through this, I found out that there were about 6. So we're going to talk about different things in that. So who the heck is this guy? I'm Adam. I do stuff. But yeah, big nerd. That's all you need to know. If you ever see me just kind of blindly standing in a corner and I start doing something like that, it's probably just karate. It's just martial arts. I'm really just quite goofy, odd. It's okay. Just look the other way, pretend I'm not there. Life will be good. If you're looking for me online, I don't have that much out there, but you know, just go ahead and poke around. So what are we going to talk about today? Well, I also want to talk about what we're not going to talk about. We're not going to talk about the history of promises. There's a lot of stuff out there. I have no idea if I'm right. I wasn't around using code during then, so we're not going to really talk about that. How is it changing? Everything's changing in JavaScript every day, and I think that's great. Not going to really be talking about that. I'm not going to talk about the API too much and not about the spec, but what we are going to talk about is, you know, browser-focused use, when to use it, some libraries, not going in depth about them, and then the patterns. That's really the meat of what we're going to be talking about today. So using promises, what are they for? How do they work? What do they solve? How are they bad? What tools are out there? You know, basically I want to put together a base level of what understanding, what kind of concepts are we going to walk through this particular discussion about. The interface, the life cycle, and again, what are they for? So promises. There's a lot of stuff you can do with them, and it's different depending on what library you decide to use. You'll notice that this group right here is really what the spec really focuses on. And yet there's a lot of other functions inside here, and it changes depending on which library you use, depending on how far back you go, how many browsers you need to, you know, actually support, how far back you go with different support structures, the different maintainability. The list could go on and on and on. And again, I don't want to bore you with the details because I honestly don't know all of them. But you'll also notice that these down here are really important. The bolded ones, again, are the ones that are really important for our spec. But the ones that are actually here for the static here, these are really useful things, but not necessarily in spec, but they're out everywhere. Get to know them, get to use them. It's really important. So a couple terms that I want to make sure that we cover. State, fulfilled, resolve, reject, chain. You all know them, right? We're done? No, I'll actually talk about them. The state, it's something that we use inside of code all the time. It's just the way it exists. Fulfilled is just really the question of, is it resolved or rejected? Is it at the next point? Resolve, successful, reject, failed, unfortunately. And then a chain is something that we're going to be using to describe a collection of these promises, things gone together. So let's talk about a life cycle. I'm hearing that word thrown around a lot this year, and last year not as much. Just to reiterate what that is, it's really like the chain of events, the way that something lives, the way that something operates over the course of time. Now inside of promises, promises actually give promises. Promises produce promises. Life cycle is not just how it is, it's how it's reproduced. So it's really important to think about that. So the way that our promise goes is we create it. At inception, it's just like a thing. It does stuff. Now you might actually say, hey, I want to resolve this. It brings us to a successful state. The fulfilled state, this is the resolved. Take green as resolved. We have a couple options for that to actually be. It could be then, it could be success. That's how you would handle that particular resolved state. After that, we're brought to another state where it's basically the fulfilled, we're done, moving on. Contrast, you can actually say, what if I rejected it? That would bring us to that red state. When we're at that rejected state, it's still technically fulfilled. And a few of the ways that this can actually be processed inside of its life cycle is catch, then with the second particular parameter there where you're actually passing in a function, or fail. So if you see any of those anywhere in any code, because if you're like me and you have to jump from code base to code base to code base, not really knowing what you're going to be looking at next, it's really helpful to know what is the general sense of what a promise is going to look like when I'm going to work with it. Lastly, you'll notice that when we're done, it also comes back to that fulfilled state, even though it was technically rejected. Some libraries also come with the done function, which I think this was mostly a jQuery thing, but don't quote me on that. But that done state is kind of like the after all the thens and the rejected. We're done, stuff happened, we're going to move on. And once we're done with that, we're done. And this is a very little visualization of the life cycle of a promise. So what are promises for? Well, one of the things that I like to do when I talk about promises with people that I'm working with is there's usually two models that we have to contrast with. We have events, which typically happen from the DOM, things that you're clicking, things that you're operating on, and we have promises. But the truth of the matter is they're both absolutely asynchronous. So let's do a little compare contrast and see how these two things are different. Well, promises tend to be singular. A lot of the discussion this time around for Midwest JS has been around functional programming, I'm probably going to say it wrong because I'm learning about it now myself. Reactive functional programming, which kind of introduces promises that happen over the time. So that singular question now becomes that plural or reoccurring thing. But promises in general are going to be triggering at a single moment in time. You're going to be asking them to do something and then come back. Whereas events are going to be happening whenever the user damn well pleases, or whenever the actual system pleases. So with that said, promises have like a request response. They have a start and an end. It's finite. And then we have events that are sporadic. They happen when they happen. So a couple comparisons of what we have there. Promises generally are emulated by network requests. That's a good way to visualize them, mentally think about them, how they work. And events are around UI events. It's like a click, key up, key press, key down, just whatever you need to do with that. And so some actual use cases of them that are not the traditional that I just mentioned here are some file I/O that you see with promises. You can do that inside of the node space. And then you also have some socket connection, again, node, or even on the browser when we're listening to sockets communicating back to us. So let's talk a little bit more about events. Again, we're kind of getting that base ground level. Let's figure out where we're going to go from so that we have to know where we're starting from. All about context. Events are repeated. They have some frequency. They're unpredictable. They could be predictable. I mean, we have things like set interval. We have click that's going to be absolutely unpredictable. So, I mean, it all depends on if it's repeated, it's technically an event. So that's going to operate something like this, where over time we're going to get these little nodes, different things that happen over the course of time. Promises, on the other hand, are a single event. They may have some sort of progress. Again, this is non-standard, but I've seen some different libraries use this, and sometimes it's useful. Sometimes over maintainability cycles, it's ended up not being so useful. But it has an entry and exit. And how that ends up looking is we get a start, something happens over the course of time, and we're done. So, that's really good. And a lack of fulfillment, really important to note, is that means this whole line doesn't actually occur. We don't get to the end. So promises kind of become a liar. And that's not so helpful. But it's important to make sure that you're resolving, rejecting, just fulfilling these. So why are promises even relevant, useful at all? Well, they solve some problems. Some of the problems that they solve are readability, maintainability, and undesired side effects. So readability. It's a software engineering concern. And it has to do with how well do you perceive the code the moment that you see it. And that's really important when you got to hop in, hop out kind of thing. What about maintainability? Maintainability is not just that, but it's also how much can I change this and it won't affect all these different files? How easy is it to make updates? All of that. And promises can help that. That doesn't mean that they are the utmost silver bullet, the thing that's going to solve our problem, but it's still a thing. What about undesired side effects? This is another discussion that I've heard that I'm not super familiar with, but I know I've had plenty of pains and probably lost a little bit of hair over. But effectively, it's things that are happening in a place that shouldn't. So let's dive deep into that. Again, look, code, don't worry about it. It's hard to look at. It's hard to understand at first glance. When promises were first coming around in some of that old legacy code, you probably had to come into this and be like, how do I refactor this into something readable, something usable? Well, I mean, the best way to do that is let's break it apart, right? Okay, well, we have some sort of form that's submitting something. All right, that makes sense. We got a callback. That's when something happens. Ajax, cool. I got something that's being called in there. All right, some sort of resource, whatever, don't care. I'm going to serialize whatever data is inside of the form. It must be something like a submit. Oh, look, it's successful. Good. I'm going to update the form. Hey, oh, I'm making another request. All right. Now we need to make another update. Okay, so that's readable. It has that callback hell effect. I'm sure everybody's had their own experiences with that. It's not always great, but it is a thing. So what about when we maintain this? I got to add another request in there. This just became even worse. Now we could have modified it. We could have refactored it. We could have added functions. I'm hoping everybody in here is cringing right now. That's how I feel about it. But let's walk through it again. We got the same form submission. We got the request that's happening inside of here, little success action. Then we have another Ajax request inside of here that is now the wrapped inside. So we had to make an Ajax request before the other request because we had to do something. Admittedly, these particular examples are contrived, but trust me, they've been implemented before, frustratingly. So we keep digging inside of here, and we eventually come to the very end. And admittedly, I just wanted to see it did this, then this, then this, then this, then this, then this. And instead, you got to crawl your way in, crawl your way out. And in order to make that change, we had to make a bunch of things move in. And if somebody else made a change in there, you're probably going to get a conflict. And hopefully, everybody is going to be OK with what's going to come out of that. As long as you don't have a big team, should be just fine. What about the undesired side effects? This is a common manifestation of asynchronous tasks. Calling asynchronous tasks unexpectedly, whenever we're doing something like this, I have an update form. I wanted to update it. But now somebody needed to find a good spot to make a change. And when I made that change, I needed to make an Ajax request, just something that needed to happen. But now I need to know when that's done because I might need to make another request, might need to make another change, might need to do something after the fact. So now I have an undesired side effect. Technically, it could be updating the form, might not be, who knows, it's just making another request. So let's change that a bit. Now we have to add an onSuccess method, or a callback, so we can handle what happened there. We have more problems that are generating themselves. I mean, admittedly, we talked about callbacks as a contrast, and callbacks aren't the problem, it's the way that we wrote the code. So we can use promises as a tool to change the way that we're working with this. But on the other hand, just because it's a promise, just because it's a new tool, just because it's useful, doesn't mean it's actually going to solve all of our problems. Again, not the silver bullet. I don't know about you, but every single time I find a new thing that's really cool, I think, yes, this is going to be the one thing that I need to do the project that I wanted to work on, the next thing I'm going to be doing. And you get there, and there's just this one part that just doesn't quite fit, and you're like, all right, just fell apart. Just throw it away, come back, do something else. Or you're working with it, and you find that there's weird things that have happened over time. So with promises, they do make problems. They have overhead problems. They have error tracking problems, which we'll talk about. And quite frankly, they're hard to grok. They're hard to get. It took me a while to figure out ways to use them in non-standard ways, things that you needed to use them for other patterns, other approaches. So again, let's visualize this. Overhead. What's in a promise? Well, without talking about the spec or API in detail, whenever I make a promise and then do it then, it creates another promise. And that promise could store functions inside of it. Now that doesn't sound all that big of a deal, but as we go, we're going to add more and more things on our stack. So now we have a lot of things in memory. Now again, I do creative coding, I do visualizations. Oftentimes what people are asking me to do is take some sort of canvas system, SVG system, and push it to the limit. If I need to have stuff in memory, I want it to get out and get out quick. And having to do something where I'm having to queue up a bunch of events can be difficult for that. So it's something to keep in mind. Promises can be slow because we're processing a lot of stuff. They can be difficult because there's a lot of objects. It's a thing you got to be at least aware of. So error trapping. If you've dealt with promises, you also ran into the problem where your promises magically failed and it didn't tell you why. I don't know why that happened, but it certainly made me feel like that. You know, like error trapping is just something that promises do. Promises can interpret errors as the rejection state. It's a thing, and we have to be able to handle it. We have to know that it's there. It's Beaker would say, what? You know, it's hard. So more about that difficult grok. This is a word I thoroughly enjoy using. You know, it means to understand profoundly intuitively. Just because you can swing a hammer doesn't mean you know what it's all for. Zombie invasion comes, you're going to use it on a zombie? I would. If it's a sledgehammer, I probably wouldn't use it too many times because I'll probably break the wood on something, but then I got a nice big thing I can chuck at something. Either way, again, what can you use your tool for? It's not about just what is your tool, it's about what you can use it for. So it's hard to grok. This thing is extremely expansive. Every single time I see people using it, they might use it in really profound and unique ways. Or they might use it in ways that just make you turn your head to the side and go, what? No, take that, throw it away, try again, do this other thing. It just depends on who's using it, who's wielding it, who's making use of it. I don't know. I just don't know. So knowing your promises, what tools can you use? It's an important question, and a lot of times when you're coming to a big meeting of the minds, you want to know, what are all my options out there? Now that I want to use some really good things, what's the new one? What's the good one? How have we proven things that are wrong? I'm going to tell you, I don't really care. Pick one that works for you, learn it very well, but I'll give you some options. So we have Q. This is one. I have no problems with Q. It's actually been very useful. However, when I learned about error trapping was when I was using Q, and I got really frustrated with error trapping and not knowing why my code broke. So that I have gone away from it, but I know it's a very good tool because I've also used it on projects where people were effective with it. Very useful tool. Bluebird, also a very useful tool. jQuery, that's where I started and found lots of problems. But again, these are tools. Learn the tool that works well for you. All of these will suffice. We move into RSVP, which I believe is underneath Ember. And then we also have ES6 promises moving into that shim space. So it's great that we have these tools, and if you ever try to write the spec real quickly, you probably won't have a good time. It's kind of hard. So going to the spec, we're going to be focusing on mainly the A+ spec, plus a smattering of those functions that are down in that static area, the all, race, which I don't think we're using race, but resolve and reject. These are all really important to what we're doing with promises. And we really got to consider how we can use these. So again, A+ spec, that's what we're going to be focusing on. There are other discussions out there for it. Either way. jQuery. So when I first learned about promises, people were just beating down on jQuery, and I couldn't figure out for the life of me why. And if you worked with a Drupal site, you'll know that sometimes your versions of jQuery are really old, and sometimes they're new enough, and you never know what you're going to be getting. And so sometimes you just got to go jQuery.fn, jQuery version, something like that, and you'll actually find out what version it is, and then you know what you're dealing with. Well, the truth of the matter is, less than 1.8, yes, you can look in the docs to find this, but less than 1.8, it chains, just like jQuery typically chains. It chains your promises. So that means that every single time I call then, this isn't doing what I mentioned before with the overhead. It's using the same one. So I can't get that awesome serialization that you're going to see. 1.8 on, from what I've experienced and read, it does act differently. It acts a little bit closer, but it still doesn't conform to the spec, which is the reason that people generally bash on it. I also have heard that in 3.0 it's going to be updated, which is great news, and I've heard it's going to be going under the spec. I don't know that myself, but from what I've heard from everybody, the answer is yes, and that's great news. So for everybody who does use jQuery, which tends to be in the browser space at least, a very common tool, there's something to look forward to. You might not need to pull in another promise library if you need it. So again, I don't care what tool you're using. And for this presentation, I'm actually going to hop around between different things because these are derivations of code that I've written on different projects, different patterns that I've used. And we're going to walk through these patterns, and I'm going to let you know that it is pseudocode. They are contrived, they're modified from what they are. There might be a few typos in there, but they are derived from code that was actually in production, but due to various reasons, I can't really show you all the code. So let's talk about patterns. Patterns are a thing that we use inside of development. Software engineering patterns, design patterns. We build out patterns inside of a project's architecture. We really need to identify how this code is going to run over time and how everybody is going to conform to that. I'm in the business where I need to be working with software engineering teams who need to be doing things in a similar way, so when I come back to the code, I need to know what to expect. And every single time people run into a different problem, it can become very difficult to work with. So, welcome to the meat of the presentation. So we're going to talk about 6 different patterns that I've given names to, and again, what are the 2 most difficult things for a developer, for a programmer? Naming and caching. Luckily, I don't have to cache anything with this except for stick it in my computer and call it done. So naming. We're going to talk about interfacing. So interfacing, it's like helping hands. This seems pretty obvious to a lot of people when you work with it, but it's something that you need to set aside and get done the first thing you do with the project. Otherwise, you might run into some problems. So our problem is that promises, by nature of where we came from, are not native, and they require extra work. So we can have numerous asynchronous functions inside of JavaScript, set timeout, and all the Ajax processes. We can start moving into some other areas, and they are not promise-driven, so we don't know when they're done without a callback. We now need to work away from that, which a lot of people call, in some different libraries, I believe, Promisify is one of the things I've seen. And the solution is, therefore, to map these asynchronous functions into something that you can reuse. In projects where you have to build the boilerplate from the ground up, or things where you need to work through these problems again and again, it's really important for you to identify these utility functions. I believe the library Axios is floating around this year, and that's, for example, a good utility option for Ajax that ends up producing promises. So commonly in the projects where I don't have the luxury of different libraries, you got to write a quick wait function. And this uses I believe the spec version of the promise, where we just have a promise wrapping the set timeout, we can call resolve. So now I can have a wait function that says after a certain period of time I can do something. If you've used Angular, $timeout does the same thing. So this is a very useful thing. It does a little bit more. You can correct me about that later, but it does do a little bit more. So we also have a request. This is a very rundown, not very helpful, not even great implementation, but I just wanted it to articulate the point. When we're making an Ajax request, we need to know when it's done. And this is going to provide us with a promise that's going to tell us when it was done or failed. So again, we're providing an interface. This is nothing new to anything that we do with code. Whenever we have something that doesn't work the same as another, we need to provide some sort of adaptation to the interface so we can work with it. So I work with graphical things. Normally I like to dig inside of OpenGL, but honestly that gets a little hairy in there. That can make my head hurt. I like it better out here where it's clean. And so CSS, we have transitions. Now oftentimes I see people working with the transitions as things that happen in between, but sometimes you don't want that transition to just be an in-between. It's not just the glue that holds it together. It needs to be something that you can tangibly hold on to inside of your code. And so then we can introduce, what I like to do is an animation between them. A good example, if you don't play video games, this isn't going to mean much to you, but Metroid Prime, if you've ever worked with a GameCube, you know, well, Nintendo stuff, it's pretty durable. And we took a few experiments. We took a GameCube and threw it off the top of our house a couple times to see what would happen. Would it still work? Because Nintendo stuff is pretty solid is what we found. It did work, but when we played Metroid Prime, there's a section in the game where you have your gun, if you know Samus at all, she's running around with her gun, and you have a left D-pad that you can change the use of the gun to a different mode. Well, when you're doing that, the thing opens up, these cool little graphics happen, and then it closes down, and now you can shoot with it. What we noticed, though, is the GameCube we very trollingly threw across the house to the ground. It ended up moving a lot slower. Obviously, we broke something in it, but dumb kids doing something really dumb, maybe not kids, just really stupid. We took that and we saw that it would open, and then you'd hear the thing wheeze and try to figure out what it's doing with this processing. And what I realized is that it's hiding all the memory that it's trying to gather and cache and get ready for this physics engine. So animations can be used during loading periods, and therefore I need to know when that's done and the loading's done. Something that most people use, but promises can also be used in that capacity. I usually see people using it for data. I just really wanted to articulate that you don't have to just use it for data. It's useful for other things too. It's very useful for other things. And I oftentimes complain at my developers when they are not using them for animations because I don't want to have to write it every time I'm working with it. That's just me. So a good example of that is I want some sort of interface to enter. And when I enter, thing's going to appear, and then we got our then. So that was the code that we had. Yes, contrived. Yes, Keynote. It's not actual code. But believe me, that system does work. I use that all the time. It's a very useful tool. And lastly, this was an experiment I put together. I wanted to see what I could do with web workers. Again, graphics. Physics is a thing. Physics is hard to work with. There's a lot of calculations you got to work with. And maybe you want to have thousands and thousands of particles on there. Well, if I have to do thousands and thousands of particles of work well between every single rendering step, that's a lot of work. And it slows things down. And as long as you have your rendering pipeline pretty well built, you don't have to worry as much about it because now you're worrying about the actual CPU of it as opposed to the GPU. And so what if we take a web worker and take some really hard work, shove it off to another core, and let it tell us when it's done? You can therefore make this promiseable, however you want to word it. But web workers are yet another thing that we can change the interface for. And these are just some examples. There are so many more things that you can do. So interfacing, that's really the first thing that we need to be aware of when we're thinking about what can we do with a promise? What tools can we bring to the table? Now this is kind of the start of what we can do. It's useful, we see it every day, sometimes we take it for granted, but we do need to be able to take advantage of it. So let's fulfill some lies and rejection. I really, really, really want to steep on that rejection because I'm a control freak. I need to remember why I made that mistake. So the problem here is that promises devour errors, and it makes debugging difficult. 2 weeks ago, I ran into a problem where a developer was working on a system that I had written a while ago, and I couldn't figure out what was going on because everything would happen and then nothing would work. No errors showed up, no nothing, and it was all production code. They had the source maps pulled up. We didn't really get a good debugger statement in there. There's nothing really we could do except for, oh yeah, promises. They make things difficult when you don't actually prepare for errors to happen. So the solution then is to catch errors and pipe them over. And if you have any particular patterns that you like to use with that, I'd love to hear them. I haven't found one that I feel 100% suitable to say this is the silver bullet. But the truth of the matter is when you're working with errors and you need to catch them in between, you don't want them to just go to the rejection state all the time. Sometimes when you're developing, especially when you're developing, you want it to explode in your face and then start everything on fire so you can actually spray it off and figure out what's wrong. Makes life easier. So oftentimes what I like to do is I'll pipe it over to an on-error function. If you're not familiar with this function, great thing to know. It's basically where all of your errors get caught. But the problem is that with the promise, we're basically wrapping everything, at least what I think I understand it as, is a try and a catch, so everything's being caught in between. Again, don't take my word on that exactly. Take a look into the code, know your tool. Rip it apart, make sure you understand it. It's like a carburetor. Take it apart, put it back together. If it doesn't work, do it again, do it again, do it again. Can't get it that time, throw it away, just come back later. So we're going to have the situation where we have an irrelevant error. Who cares? We just want to prove that it broke. And then typically what you're going to have is you're going to want to handle an error. So the way that we can handle this rejection, this problem that we're having, again, we want to steep on this. We want to really take it in because I need to know every single time that these really complex promise chains break because it's really, really hard to follow. So on the handle error, we're just going to apply that over to the on-error function. Again, I haven't found a way that I feel really solid with, but using console.error, since most of the time you're doing development inside of Chrome anyways, seems to be a sufficient one. But if you have a better one, I'd love to hear it afterwards. Again, learning new things all the time. There's so many ways to use a tool. It's quite incredible. So what this ends up looking like is we have a window.onError function that has that console.error. Again, only valid if you have the console.error function, which is only in some of the browsers. But still, most of the time we're going to be able to work with that. And these kinds of things don't manifest themselves as often inside of the older browsers. And so then we're just going to handle the error coming out of the promise, and making sure that you have that in there whenever you're doing development should be really helpful for you. And if you don't have an on-error strategy like, oh, I found an error, post something back to the server, or oh, I found an error, let's post something back to our exception tracking system, make sure you get rid of those so you don't suddenly blow everything up, because that nice handling of things can be very helpful too. So we've covered interfacing, we've covered error bubbling. Let's talk about the synopsis. Now this one's one that I've had a hard time giving a name to, but one of my devs on my team mentioned to me, we were talking about the whole MVC paradigm, which I don't hear as much today talking about, but he was trying to explain to me what a controller is, because that's the hardest thing I feel like everybody has to talk about, is what does a controller do? And he says, it describes the narrative of your code, and I was like, fantastic. I have never heard somebody say that. Yes, it is the narrative. Well, promises are also useful for defining the narrative of your code. When you write them, you can actually see individually what is going on inside of it. You can make it clear, you can make it useful, you can make it readable, help it become more maintainable. So what is the problem? We have inline functions, which you'll see in some of the later examples. I just have for brevity, just to be there. But inline functions aren't always readable. Anonymous functions, as you've noticed from the original keynote, he was taking some of these anonymous functions and putting them into sum and some of the other functions. They aren't always maintainable. If we have function inside a function inside a function, or function after function, suddenly it goes above one of the other devs. They call it their middle finger rule. If the code is bigger than my middle finger on my screen, it's too big. True story, true story. And if you ever catch him doing it, he just kind of turns to you with it out. Oh, I didn't see you there, because he's clearly very busy. So the solution is to refactor it. We've got to break it apart. Bring in some naming. I mean, it's one of the hardest things we have to do. Take some time, go through it, fix it. And we need to define what the narrative is. What am I trying to do? So look at this code. It's kind of gross. It's kind of the point. Stop looking at the code. It has bunches of parts, right? We're going to create a new entry. Basically, the approach I'm going to be taking with this is, what if we had a strict RESTful API? Now, many people are going away from that today, which is due to experience. So sometimes you need to use it, but take a strict RESTful API. It has very strict rules of how you create, update, delete, maintain, just change everything. So we're going to create a new entry. Then after that, say it didn't actually return all my entries afterwards. I need to gather all my entries again. So I've got that prepared. Next, we need to link the entries. Because suppose in this particular function, which I believe I made, create and link entry, we need to link this entry with another one, something else outside of here. Again, contrived, but has been experienced. I'm pretty sure everybody's had some sort of exposure to something like this. And suppose that fails. If that fails, then, oh, hey, I need to, and notice again, the null and function, I need to go ahead and delete that after I'm done. Now, admittedly, this doesn't handle the situation of what happens if that fails again, but bear with me. Again, we got an example here. So now we have our general idea of what we wanted to do. This doesn't say create it, link it, delete it when I'm done. So let's break it down. We're going to have the create entry function. Now we have this that just returns a promise for the one thing. Pretty simple. We're going to make a post. It's going to create something. Next, we're going to fetch all of our entries. We want to gather everything that we're working with and just end up using that throughout our particular interface. After that, we're going to link the entry. Now, you'll notice here that we're passing in a couple variables. We're staying away from like the object-oriented instance, because it is important when you're working with these to know how to bind, where to bind, what's a good approach. This is one example, but you do need to consider how you're binding it in this, so you can make your code still readable and make it still comprise a synopsis of what your code is doing. So here we're going to patch the entry with the other entry that we already have. Now we're going to remove it. Now that I'm done, let's remove it. Let's get rid of it because something failed. I don't really want to ask any questions right now. We might need to make it to be automatic later. We could have the user pick something out, but honestly, it's kind of odd to have them go through an interface for something that just failed. So now this is going to change a bit. And bear with me, I used a little bit more of a stateful trick here with a little DTO object where we did some sort of from JSON transformation from what was coming over to the server. So we could pass things over based on reference. But effectively, this changes everything. Now we have a synopsis. This is our code that's running. So when I want to create and link an entry, I can literally say, oh, first, create my entry with the data. Then I want to prepare my response. And if that fails, I want to handle the error. Next, I want to link it. And this is where that bind becomes relevant. I might want to use this in some of the examples. I suppose that's why I have this fancy thing. See, learn to use your tools. Might want to use this here, but then we also have the entry and linked ID. So this is all about using that entry so we don't have to have everything necessarily in the same scope. Finally, we're going to move down into the last block, which is, again, that failure state, because now that I'm done, I want to see that it did end up removing something if it did fail, again, causing that error. And so that effectively provides us with code that can describe what's happening. It becomes that more expressive code that does say what it is. It starts looking a little bit more declarative, even though it is imperative. Again, remember the use of bind. You can use the var self equals this. It doesn't always lend itself to it very well in this particular pattern, but this is a useful pattern to help maintainability and readability. So we've been through interfacing, error bubbling, the synopsis, which is something that I found really helpful. It's usually a refactoring pattern. Now we're going to talk about rejection. This one's really important for control. We want to be control freaks. We're going to maintain rejection. Again, I want to really, really feel that rejection. It's got to be there. I'm sure everybody's been there, right? No? All right. I must be alone. All right. So working with the problem promises fulfill the success normally. Now, I thought this was kind of a given, and I didn't really think too much about it. But one day, one dev came to me with a promise chain, which admittedly should have been refactored in different ways. But I think it had about 20 or 30 different requests going on inside of there. Yikes. That's from the browser, not inside of the server where it's aggregating stuff. It was on the browser. It was a lot of stuff. And it suddenly failed, and you couldn't figure out why. It wasn't working on the intended path. So the way that we do this is we got to force our hand. We got to force the error state. We got to make sure that we reject it. It needs to be bad. So let's take a look at our life cycle. So I create a promise, and normally it resolves. When it's done, it moves down into another resolved state, or what we could treat as the neutral state of the future. On the other hand, when I go to a failed state, this ends up just failing over here and then going over to our next neutral state or resolved state. So if I have another link in that chain and I'm trying to listen for that error state, that becomes a thing. Now if that failed and I didn't do anything other than handle the failure and say, okay, cool, we're done, now everything continues as needed. So this really lengthy process that he had ended up producing this problem where it just failed outright and then continued trying to load everything, which failed more. We don't want to fail more. We want to fail and be done. I want to fix the thing that broke. So the way that we do this is we end up wanting to target this guy, again, using your tools, and we return that promise reject. So one of the tricks of promises is that a function can return a promise inside of it, inside of the actual call, and that allows us to have the next promise in the chain wait for it. So this is really a thing that you got to consider. Oftentimes people might forget a return statement inside of their promise chains, and you can't figure out why suddenly your asynchronous chain is out of order. This is oftentimes what you need to catch some of those errors that happen inside of there. All right, so now we're going to go into a couple of the things that really made my brain hurt when I was working through it, and it took me a while to get my head around, which after hearing about some of the newer tools that are coming down the chain would really help. But I'm going to show you some of the a little bit more like, I still have a hammer, I'm going to keep hitting the rock as hard as I can, because it does work, and sometimes it's what you have as an option because, again, maintainability's sake. So the first is nesting. Promises are inherently capable of being used in a nested fashion. We can use them inside of each other. That's the way they've been built. There's an infinite number, well, pseudo-infinite number of ways that you can use a promise inside of each other. So the problem is that a problem can be complex. The thing you're trying to solve can be difficult. It needs to be broken down. We need to break everything down into subproblems, just like we do normally for work, for any sort of problem that we're trying to give a solution to. So the solution then is define each subproblem as a process of its own. Nest your promises. Work with them together. So again, let's try and take a high-level look at this. How does this actually operate? So this is just a general promise flow. It does stuff. Let's not worry about what's inside, because the truth of the matter is I want to treat this as its own block, its own unit. So now this promise, which has potentially 2, 3, 4, 5, 6, 7 different layers, is now just the one that has where I'm going to start and where I'm going to end. So now we have that little black box figured out. I want to create chains of these, scores of these little promise structures that are going to work together so I can have this basically a hierarchy of processes, or try to map out my process together. So then we're going to identify our next one. I have my resolved and rejection state, but I need to be able to handle that gracefully because now I'm going to nest these inside of each other. I don't want to worry about what's inside, so let's treat that like a black box. Next, after we're done, I might have two different chains I need to go down depending on what's going on here. Well, I need to treat my center one as a black box as well. So then let's move to another step where we just treat all of it like it, and suddenly we have a promise that is now simple to think about, simple to work through. And that's really the trick of the nest. So here is a pseudo-concrete example. Again, presentation, not code. But effectively, what if I have a modal that I wanted to pop up, load some content inside of it? There's going to be several steps that come inside of there. After it's done loading, we're going to suddenly get our items in. We needed to have these animations in here and the different loading things in there, because maybe I don't have everything cached, maybe I do. Doesn't matter. It could be asynchronous, so we got to treat it that way. So let's break this down into what functions are we going to be using. Well, first, I'm going to be fetching all entries in show modal. Treat these as happening at the same time. They're called in the same synchronous stack, but they're happening at the same time. I need to show something. I also need to get all my stuff. But now after it's shown, I really need to show that loading modal. And I don't really care about whether I'm done fetching or not. I need to show you that it's loading, because that way you know it happened. And this is where we use one of our wonderful static methods. Now everything's done. I grabbed everything. We've hit that point. The raise condition's over. I don't need to worry about it. Let's hide the loading spinner, because I could have hidden it sooner, but it would have been wrong. Now that it's hidden, I just want to display all the entries. All right, so now we've taken an interface that has a loading process and we've turned it into something that we can comprehend. Again, taking this problem and breaking it apart. And note this little block here where we have a modal and a show loading spinner in here. We're creating a substructure in here so we can have a sub process. I could move that unit around if I wanted to. Let's look at some code. So we're going to use the same fetch all entries function. Just, again, it works. Show modal. Again, we're changing libraries. We're going to use velocity this time. Great tool for trying to hop around for different animations inside of there if everything needs to be dynamic and you can't use CSS. Honestly, you probably could here, but let's just pretend that you could. And velocity also has a couple hooks that provides a promise out for you from the animation library, which is really, really useful for that. So we're going to make an animation. We're going to have the box, the big modal in there, and just kind of show. And let's show our loading spinner. We're going to animate that little spinner. It's going to be a GIF or GIF, depending on which side of the fence you guys stand on. It's going to just kind of be up there and spinning, and once it's done, let's add the class for active. I'm a big believer in the states come from the class rather than having the states come from the styles that are inside of it. Styles are important, but once it's there, it is active. And once we're done, let's animate it off, and then let's remove the class. Because, again, we're using a tool so we can actually catch when it's done rather than using something else there. Once that's done, we're going to display entries, which, again, we're going to animate after we've done some work. Just bear with me. Somebody forgot to code that, and I got to get on that real quick. But after it's done, we're going to mark that as also active. And note that each one of these methods have had subchains inside of them. So now we've isolated subchains that are very relevant to their particular process flow, and now we have a nested code base. So there's at least 2 or 3 levels that we didn't even identify before because they weren't relevant as things that I really need to worry about. They were things that happen inside of the DOM, so it's specific to display entries. So then we look at our synopsis of the nested structure, which we could break out even more if we really wanted to isolate some of these concerns. But the point of this whole discussion is to show you. So we're going to transition to the page. We're going to fetch all the entries, show the modal, then obviously show the loading spinner. And once both of those are done, we're then going to hide it and display the entries. Works pretty well. So let's see how that looks when we're working with it. All right, those two happened. Show the loading spinner. Cool. Hide it. All right, things must have come back in. Display the entries, and we're good. We're golden. It works. Let's go to the last one, looping. This took me, I think, a very long time the first time to really understand, and it's very useful for very specific things. It has to do with making the pieces come together in different ways. So the problem here is that we have many repeated steps. Again, it's called looping. We got to loop through our promise. Steps may have many small steps. Again, going back to the nesting, let's just assume that that's correct. In order to solve that, we really have to queue it up. We have to gracefully handle nested promises. We need to work with this. It needs to be automatic. Because when we're working with something that needs to loop, it's oftentimes an automatic problem, something that can't be solved with a human interaction between. That's not entirely true. There's ways to get around that. But it's still something that you got to keep in mind. Automatic means that there needs to be some form of automatic wait inside. So we're going to look at our example again. The example that I use this for is a multi-file upload. That has a lot of steps inside of it. It can be a little rough. Again, moving to that strict RESTful API. but they had to add in a little hook so I could upload the file and link it to it. So the way that ends up looking is we have their file that comes in here, we end up loading everything, stop, and oh, I guess something failed. That's not so great. But now that it's done, I need to tell the user that something happened. I didn't want to have user interaction between. I wanted to make sure I was able to continue going through. In this particular example, assume that we're building a web application that's going to be working with big volumetric files for, say, an X-ray machine, or it's not really volumetric, MRI machine, CT machine, and I got to cut everything apart so I can have the smaller images. So there's going to be a lot of work for every single file that I upload. And here's a refresher. We're going to treat the black box out again. So I have one type of things. Pretend that this guy is an upload event. Well, I'm going to have n number of upload events, depending on how many files I wanted to upload. Now that I have these in here, let's just treat them all the same. And when I have them, I need to chain them all together. So effectively, they all come together, and you work with them in serial, and so that everything can happen one by one. Because again, we don't want to bog down the system. These are a lot of images that we're going to be processing. It's very big, very, very heavy. So our first method, we're going to look at process file. Again, everything's out in the open, so we can take a look at it. You don't have to spend too much time trying to break it down. This was built at the time with Angular, and Angular ends up, we built these very RESTful service calls where we have our get, which after that we're going to have to update a model so then we can save it, because the get was only going to get me the initial instance. Once that's done, we had to start the upload, and this is going to take a while. We're not going to look at the upload code because that was a little gross, but it was a thing. After we're done, still got to work on the loading indicator and showing the success indicator, but that's there. After we're done, we're going to delete it again, because if that failed, that's a lot of potential cruft that I wanted to get rid of. And that's basically the loopable option that we're going to be looking at. Now we're going to upload and link. This is the core of it. And what the real magic comes from this is looping through every single promise that we're doing and basically taking that reduction method that we see inside of functional programming and taking these promises and turning them all into a big chain of what you need to work with so that each time they're done, that they can be worked on in serial. Because we, again, have an automatic system that needs to be resolved gracefully. It needs to happen. And if something failed in between, I need to continue. It needs to happen. These are critical files that I need to have uploaded. Take a little bit to look at this. It took me a while to figure out how to write this, and it takes me even longer to understand it when I'm working with it, but it's really helpful. And again, Angular, we got Q, which we can use when, and that's effectively the promise.resolve, which I do not believe is inside of there. After we're done with that, we have to take that and handle the erroneous files. We're done. We have everything. Let's show the user what failed so they can try and do it again. They can see it, everything like that. And then we have our upper level synopsis for what our lower level synopsis is going to be, which is the mini links inside. So again, let's take our interface and break that apart. We start the upload. We're going to process some files. Now let's process the file. We got 1 going. All right, it's done. 2, let's get that. Okay, that failed, but we got to move on. 3, that was quick. 4, taking a little bit longer. All right, good. Now we got to go ahead and handle those, and we're done. So effectively, we can take a system like that, break it apart into those little units, and work with it individually. And that allows us to understand and work with these complex things that need to be automatic and happen over time. Again, this is hard to understand, at least was for me the first time. If you're getting it the first time, you're smarter than I am, and that's great. You can do many better things, and I love to hear what you guys have in store. But this took me a very long time to wrap my head around the first time, and now that I've had it, I've encountered it a couple times where it's useful for these things that need to be automatic and need to have asynchronous things that happen over time. It's a useful tool. So what about some takeaways? We just talked about promises for almost an hour. That's a lot of stuff. Utilize promises if you're not already. If you are, great. They're very useful. But don't go halfway, go all the way. If you're going to use promises and then use some other asynchronous ways to do it, not so great. Use it. Use the tool. Make it do what you need it to do. This is kind of a software engineering thing, but make your code self-documenting. If your code's self-documenting, your promises become readable, and the complexity that comes with them becomes simple. You don't have to work as hard for what you have to build. It's great. I don't know about you, but I'm lazy. I don't want to work very hard. I want it to work, and then I want to leave and come back when I have to. When I have to come back, I want to make it real easy for myself again. Be a control freak. It's really important in these. We try to be control freaks about how we build our code. We want it to be the perfect way possible so I can rely on it being strong each time, being robust. But Processes are hard. We're thinking about things over time. That changes the way you look at the problem. So be a control freak. Make very distinct decisions in how that needs to go through each channel, each chain. It helps you really comprehend and grok what it is that your system's trying to do, so you don't have any questions about which step I need to take. Simplify the process. If it's too hard, break it down. Break it down into smaller pieces. Put them into smaller chunks. Make them reusable. Make them something that you can put in different places if you need to. Because if you need to handle something gracefully and fail gracefully, you can. Beware rejection. I'm being honest with you guys. Beware rejection. Errors in general, you shouldn't overlook them. Don't intend for your system to work the way you think everybody's going to understand it to. People are not. So just have something in there in case something breaks so you can handle it and know what to do when you come back to it. And lastly, it's a tool, right? Now, I'm a martial arts hobbyist. I love that kind of stuff. There's a show called Forged in Fire. Has anybody seen it? No? All right, got a couple. Good, I don't feel alone now. There's I believe it's episode 3. There's a particular part where one of the blacksmiths he's very much so a old school blacksmith. And he's working with a train spring to try to uncoil it and turn it to a knife. That's really freaking hard. And if you're not going to use power tools, it's even harder. So what he ended up doing is he was trying to, get some time in there, hammer away at this thing, and there's a part of the anvil, which is the hardy hole. It's where you put your tools. And I was really surprised, and they actually called it out in the show as well. He put that in there and used that to bend it out after it was molten hot metal, but he was bending it out there. He still used his own body to do it. He didn't use the tools, but he had a tool in front of him. He found a unique way to use it. He knew his anvil. He knew what was in front of him. And that's the idea. We need to experiment with these. And some experimentation I've seen with promises are, we have animations. That's the way I've experimented with them. I like using them for animations. It helps clean up keyframes if I need them, unless you're going to be using something like the green sock animation engine. Modals. It's really cool when you can make a modal and all the form stuff that comes with it be a promise chain so that your business logic can wait for when the modal's done and then work off of what it provided you. That's great. Multi-step processes, kind of a no-brainer. Alerts and notifications, I need to know when that's up there. I need to stop doing stuff until it's done. Workers, again, great tool. Working with anything inside of the physics engines, it's real helpful. Speeds some stuff up. So it's a lot of stuff. It's a little bit more into the applied area of using these tools. But if you have any questions, I am here to answer them. Do you guys have any? All right. Go ahead. I kind of pointed randomly. So the question was, whenever you see people test promises, you see defer. What is defer? Defer is kind of a part of the promise. It's another static thing. It's a constructor for it. It allows you to create the promise so that you can resolve it manually. It allows you to kind of use it inside of other functions. So rather than having a promise that has a resolve and reject function, it kind of inverts the way that you work with your control. I now have an object that has a promise inside of it, and I can say resolve, reject, I'm done. Usually has a different API slightly, but it works effectively the same way. Does that answer your question? You also had one? Yep. So the question is basically, when I'm working with promises, do I wrap promises inside of promises? At the initial implementation, if you're like me at all, you probably just write it out to try to figure it out, and so everything is wrapped inside of promises. At the end of the day, you want to take that code and isolate it away. You don't want that to actually make your work more arduous. So what I like to do with that is I will take the promises, or at least the work that happens within the singular promise, and isolate them inside of their own function. And if I have other sub-promises, I again take those and isolate them. So if you were to unroll your code, yeah, it's promises inside of promises inside of promises. But again, looking at the synopsis, that's ugly. It's hard to work with. So we really want to have something that is individual little units of work that you can just have be reusable. Does that answer your question? Anybody else? That depends on the library and the particular platform you're working on. I know Bluebird was a pretty big talk last year, being lighter weight than some of the other libraries. But honestly, it all depends on what you're working with. assume that there is some. I didn't do a perf for this, so you could definitely go do a performance test. I don't know off the top of my head, but if anybody has that, I'd love to get that because I could put it with this in the notes. But yeah, that's a good question. The exact numbers, I do not have an answer for you, though. I apologize. Anybody else? All right, I got to say this because I told my wife I would. She was giving me crap because the first time I built this, I had too many fancy animations in between that detracted from it. So I got to put in that. So thank you for attending.